A Harvard scientist is sounding the alarm. An interstellar visitor, 3I Atlas, is shedding metallic alloys that just shouldn't exist. Real data from our best telescopes shows atomized nickel streaming from its core, but with practically zero iron. A chemical fingerprint that really, honestly, defies everything we know. Harvard's Avi Loeb is asking the question no one else wants to: if these metals aren't natural, what does that mean? The answer could upend our place in the universe, so let's explore this together. The discovery of 3I Atlas. What would you do if you saw something moving at 130,000 miles per hour that wasn't supposed to be there? On July 1, 2025, the Atlas survey team in Chile spotted a faint, fast-moving speck. The math instantly told a story that didn't fit any known playbook. Its path wasn't just a long loop, it was hyperbolic, with an extreme eccentricity that confirmed it was a visitor from deep space, moving too fast for the sun to ever capture it. This wasn't a comet on a return trip. Astronomers combed through archival data and found earlier images firming up its trajectory. The object was born far beyond our solar system, possibly somewhere near the galactic center. By the time it was discovered, it was already inside Jupiter's orbit, making a one-time slingshot around our sun before it shoots back into the void. Its incredible velocity confirmed it. 3I Atlas is only the third confirmed interstellar object ever seen, a messenger from another star that will never return. This isn't just a rock, it's a clue from an unknown part of the galaxy. The nickel mystery. Here's where the story takes a sharp turn into the unknown. Almost as soon as telescopes focused on 3I Atlas, they saw something that shouldn't be there. Data from the Very Large Telescope in Chile revealed a strong spectral line for nickel, a cloud of it vaporizing off the object's core. But what was missing is what has scientists stunned. There was virtually no iron. That's not just unusual, it's unheard of. In every comet, asteroid, and meteorite we have ever studied, nickel and iron are cosmic partners. They are forged together in the hearts of dying stars and locked into the same minerals. You don't find one without the other. Yet 3I Atlas is shedding pure nickel vapor, with iron being conspicuously absent. Harvard astrophysicist Avi Loeb, known for his bold theories, was the first to publicly highlight how bizarre this is. He argues that separating nickel from iron on an industrial scale is difficult on Earth. In nature, it's considered next to impossible. This isn't just a small anomaly. The nickel-to-iron ratio in typical solar system objects is well established. On 3I Atlas, that ratio is completely off the charts. It's a chemical fingerprint that matches nothing we have ever seen. Carbon dioxide dominance. Just when the nickel-iron problem had scientists scrambling, the James Webb Space Telescope delivered another bombshell. Pointing its powerful infrared instruments at 3I Atlas, a team of astronomers analyzed the gases in its coma and found that carbon dioxide was completely dominating the mix. The measured carbon dioxide to water ratio was a staggering 8-to-1, the highest ever recorded for any comet, whether from our solar system or beyond. To put that in perspective, typical solar system comets have CO2 levels around 4% of their water content. Here, CO2 is the main ingredient. This wasn't a fluke. The readings remained consistent across multiple observation sessions as the object neared the sun. While other gases like carbon monoxide were present, nothing came close to the CO2 spike. This kind of chemistry just doesn't align with our models of comet formation. Some researchers propose that its unique composition is the result of being cooked by cosmic rays over a billion-year journey. Others wonder if it's a clue to the specific conditions of its home star system. But the question remains, does this unprecedented chemistry point to nature at its most extreme, or is it another sign that something else is at play? The Oumuamua precedent. This isn't the first time an interstellar visitor has, broken all the rules. Back in 2017, the first ever confirmed interstellar object named Oumuamua left astronomers scratching their heads. It was traveling at high speed, had a bizarre, highly elongated shape, and most mysteriously, it accelerated away from the sun without any visible reason. Comets accelerate due to outgassing, where melting ice acts like a thruster, but Oumuamua had no visible tail or coma. This is where Harvard's Avi Loeb first entered the public debate. He controversially suggested that the best explanation for Oumuamua's non-gravitational acceleration was that it was an artificial object. Perhaps an alien solar sail designed to ride the pressure of starlight. While most of the scientific community proposed natural explanations like outgassing of hydrogen ice or its composition as a nitrogen iceberg, none of the theories perfectly fit all the observations. Oumuamua left our solar system before we could get a better look, leaving a legacy of unanswered questions. Its appearance primed the scientific community to expect the unexpected. Now, with 3I Atlas, we have a second data point that honestly defies easy explanation. Ancient sky metal. Humanity's fascination with metals that fall from the sky is not new. It's ancient. Over 5,000 years ago, in ancient Egypt, craftsmen hammered tiny beads from a mysterious iron that they didn't mine from the earth. Modern analysis of these beads from the Gertze cemetery reveals a nickel content of nearly 30%, far higher than any terrestrial ore. This was the unmistakable signature of meteoritic iron. The story gets even more incredible with the dagger found in the tomb of King Tutankhamun. Discovered in 1925, the pristine iron blade was a mystery for decades. Finally, X-ray analysis confirmed its celestial origin. The blade contained 11% nickel and traces of cobalt, a composition that matched iron meteorites. The Egyptians even had a name for this divine material, iron of the sky. It was rarer and more valuable than gold, reserved for pharaohs. This history matters because it establishes a fundamental contrast. Terrestrial iron ores almost never exceed 4% nickel. Meteoritic iron, however, is rich in it. The same questions our ancestors faced, what is this strange metal and where did it come from, are echoing today as we analyze the impossible alloys of 3I Atlas. Kilonova formation theory. So, if the metals on 3I Atlas are natural, how could they have formed? There are a couple of cosmic forges violent enough to potentially create such exotic materials. The first is a kilonova, the cataclysmic explosion that occurs when two neutron stars collide. These events are among the most powerful in the universe, and for a few brief seconds, they create conditions perfect for the R process, a rapid-fire sequence of neutron captures that forges elements heavier than iron. In the chaos of a kilonova, the normal rules of element production can be broken. Some theoretical models predict that the debris cloud from such a merger wouldn't be uniform. Instead, it could contain pockets of matter with strange elemental imbalances, regions that are incredibly rich in elements like nickel but poor in iron. If 3I Atlas condensed from one of these exotic debris patches millions of years ago, it would carry a chemical signature unlike anything from a standard supernova or our own solar system's formation. This theory provides a potential natural explanation, but it relies on an event that is both incredibly rare and violent. Asymmetric supernova theory. There is another natural forge in the cosmos, violent enough to potentially explain 3I Atlas's strange chemistry, an asymmetric supernova. Not all stars die in neat spherical explosions. Some rip themselves apart in lopsided blasts that fling elements out in jets. The supernova remnant W49b is a perfect example. X-ray maps of W49b from the Chandra Observatory show that iron is packed tightly near the remnant's core, while other elements like sulfur and silicon are distributed more broadly. This kind of uneven explosion, well, it completely changes the rules of how metals are scattered into space. In these chaotic events, the inner layers of the star, where iron and nickel are made, don't mix evenly. Instead, high-speed plumes can punch through the star's outer layers, carrying specific elements with them. If nickel happens to be concentrated in the path of one of these jets, it can be ejected in bulk, leaving most of the iron trapped behind. If 3I Atlas formed from a fragment blasted out by such a supernova, it could have started its journey as a chunk of nearly pure nickel. This provides a second plausible, though very rare, natural path to its bizarre composition. Statistical improbability. Beyond its strange chemistry, there's another red flag that has Avi Loeb and others asking, some serious questions: the object's trajectory. According to Loeb, the probability of a random interstellar object passing so close to several planets in our solar system, Venus, Mars, and Jupiter, in a single flyby is, well, astronomically low. His calculations put the odds at about 1 in 20,000 or 0.005%. For an event this rare to happen with only the third interstellar object we've ever detected is, to him, statistically suspect. Furthermore, the object's path is nearly aligned with the plane of our solar system, but it's moving in the opposite direction of the planets. This retrograde orbit allows it to sweep past the inner worlds in a way that looks almost like a survey mission. To add to the suspicion, 3I Atlas reaches its closest point to the Sun on the far side from Earth, making it incredibly difficult for us to observe when it's most active. Critics argue that in a vast universe, rare events are bound to happen. But Loeb counters that when multiple anomalies, the metals, the chemistry, and the trajectory, all point in the same strange direction, the possibility of an artificial origin must be taken seriously. The Golden Record Parallel. Could 3I Atlas be a message in a bottle? In 1977, NASA launched the Voyager 1 and 2 spacecraft, each carrying a golden record. This was a project led by Carl Sagan, intended as a time capsule for any extraterrestrial civilization that might find it thousands of years from now. The records contain sounds and images of Earth, music from various cultures and scientific diagrams, a snapshot of humanity etched onto a durable physical object. Sagan said, "The launching of this bottle into the cosmic ocean says something very hopeful about life on this planet." Now consider 3I Atlas, an object loaded with alloys and compounds that don't fit natural recipes, on a trajectory that seems too precise. The parallel is, honestly, striking. What if its message isn't written in grooves on a record but in the very ratios of its elements? A physical archive designed to survive a journey of millions of years. If its composition is intentional, then 3I Atlas isn't just a visitor, it's a courier carrying a record of another world's chemistry, and maybe even its technology. Atomic messages. If 3I Atlas is a message, how could it be written? The answer might lie in isotopic encoding. Isotopes are versions of an element with different numbers of neutrons. On Earth, scientists can already store information at the molecular level by creating unique isotopic fingerprints. By precisely controlling the ratios of different isotopes in a material, you can create a pattern, a kind of atomic QR code that would never occur in nature. An advanced civilization could theoretically bake a message into a metallic object, making it durable enough to survive a journey of millions of years through interstellar space. Such a message would be immune to the cosmic noise that can degrade radio signals. The information would be in the fine print of the object's chemistry. This is why every scrap of data from 3I Atlas is being scoured for these hidden patterns. Are the isotope ratios what we'd expect from a kilonova, or do they show a level of order that points to intelligent design? We're not just looking for a rock anymore, we're looking for a signal hidden in matter itself, a message that has waited eons to be read. The story of 3I Atlas leaves us at a profound crossroads. On one hand, we may be witnessing an undiscovered, violent natural process, a kilonova or an asymmetric supernova capable of creating alloys we once thought impossible. On the other hand, the combination of inexplicable metals, extreme chemistry, and a statistically improbable trajectory has forced serious scientists like Avi Loeb to consider an engineered origin. This isn't just a theoretical debate, it's a real object with real data that is breaking our models of the universe. Either way, our understanding has to expand. Don't forget to like, subscribe, and hit the bell icon for more deep dives into cosmic mysteries. Thanks for watching Simply Science. What if the most profound discovery in human history was made, and then deliberately buried? We're not talking about rumors or grainy photos here. We're talking about 24 gigabytes of classified NASA data on an interstellar visitor that, honestly, defied the laws of physics. Data leaked by a ghost-like hacker group revealing a 26-kilometer-wide object that wasn't just passing through our solar system but actually, actively navigating it. This is the story of 3I Atlas, what NASA allegedly found and why they never wanted you to see it. So let's delve into the data. Event Horizon's cyber attack. So how does a clandestine group get its hands on NASA's crown jewels? According to the leaked security logs, this wasn't a brute force attack, it was surgical. In the early hours of September 2, 2025, Event Horizon executed a coordinated cyber attack that bypassed multiple layers of agency firewalls. They exploited a zero-day vulnerability in an outdated Fortran-based mission planning module which honestly was just a tiny crack in an otherwise formidable digital fortress. The transfer rate was a blistering 571 megabits per second, far too fast for automated security flags to catch in time. Forensic analysts later pieced together a chilling timeline. The attackers gained initial access at 3:14 a.m. Eastern, escalated their privileges to the highest level by 3:19, and began siphoning data at 3:23. In under 7 minutes, 24 gigabytes of compressed files, including internal chat logs, draft reports, and sensitive telemetry from the 3I Atlas intercept mission, were gone. By 3:30 a.m., the connection vanished, leaving behind nothing but a silent gap in the audit trail. Cybersecurity expert Mikko Hipponen has stated that such an attack would require nation-state-level resources, suggesting Event Horizon is far more sophisticated than a typical hacktivist group. The manifesto and distribution. A data breach is one thing, but a declaration of war on secrecy is another. Within hours of the hack, a manifesto from Event Horizon appeared on encrypted forums. Their message wasn't a boast, it was a justification. They claimed the breach was a direct response to what they termed unlawful cosmic secrecy, arguing that discoveries of this magnitude belong to humanity, not to a select few government agencies. The manifesto warned that the stolen files contained information so sensitive even senior directors at NASA were allegedly unaware of its full scope. Their language was direct: the world deserves to know what its own scientists have found. To prove their point, they began a strategic distribution campaign. Blurred screenshots and heavily redacted memos were sent to journalists and channels known for covering classified science. They specifically avoided mainstream outlets, opting for platforms that would analyze the data without an institutional filter. This drip feed of information created a groundswell of speculation that legacy media couldn't ignore, forcing the conversation into the open on Event Horizon's terms. Authenticating the documents. In the world of leaks, authenticity is paramount, so are these files real? The evidence presented by Event Horizon is compellingly layered. The leaked screenshots are plastered with authentic details: bold, block-lettered confidential stamps, thick redaction blocks, and metadata tags showing UTC timestamps that perfectly match the breach window from NASA's own security audit. We see mission patch artwork in the corners, a stylized comet labeled 3I Atlas Int. Every document carries unique identifiers, routing codes, and internal chat handles you'd expect to see inside a major agency. Technical diagrams and draft tables use Courier font headers and bear NASA's internal digital watermark. We even see screenshots of the classic blue and white NASA email interface with subject lines like Atlas Intercept, Immediate Action Required, and Telemetry Review, Anomaly Detected. One partially blurred memo lists technical trajectory data, while another redacted report is marked with the access level TSSCI, denoting top secret, sensitive, compartmented information, a classification that restricts access to a small, specific group of cleared individuals. The documents bear digital signature strings ending in JPL for the Jet Propulsion Laboratory, and GSFC for the Goddard Space Flight Center, indicating a multi-center collaboration. Discovery of 3I Atlas. Before the leak, there was the discovery that started it all. On July 1, 2025, the Asteroid Terrestrial Impact Last Alert System, ATLAS survey in Hawaii, logged a new object tearing into the solar system at 130,000 miles per hour. Astronomers flagged it immediately. This was no ordinary comet. The object, soon labeled 3I Atlas, measured an estimated 26 kilometers across, roughly the size of Manhattan, moving faster than any object ever observed inside the orbit of Jupiter. Veteran survey scientist Dr. Lina Takahashi, a fictional name from the leaked files, was quoted in a log. The track was so steep the software flagged it as an error. Within hours, observatories from Chile to Arizona confirmed the numbers. The object's incoming speed of over 58 kilometers per second defied the sun's gravitational grip. Its trajectory pointed back toward the constellation Lyra, far from the ecliptic plane where most solar system debris resides. To put its size in perspective, the asteroid that killed the dinosaurs was only about 10 kilometers wide. This was over twice that, and it wasn't from around here. Impossible physics and trajectory. Here's where the story takes a sharp turn from unusual to unbelievable. Like its predecessor Oumuamua, 3I Atlas was not behaving according to the laws of physics. The leaked mission logs from July 18, 2025, show a sudden, inexplicable sideways acceleration resulting in a velocity change, or delta V, of 1.5 meters per second. The object changed course in a way that defied gravitational models. For a normal comet, such a deviation could be explained by outgassing, measured by the non-gravitational acceleration parameter A2. However, just like with Oumuamua, Initial observations of 3I Atlas showed no cometary tail, no dust and no gas coma to account for the push. Its A2 parameter was effectively 0, yet it was still maneuvering. Trajectory analysts were stumped. They ran models accounting for solar radiation pressure, gravitational pulls from planets, and every known natural force. Nothing matched the telemetry. Dr. Amy Mainzer, a leading expert on asteroids, has noted that explaining such a deviation without observable outgassing requires exotic physics or an artificial origin. The numbers kept pointing to a single, unsettling conclusion. Some force other than gravity was steering this massive object through our solar system. Surface anomalies. The armor problem. What does a 26-kilometer object from another star system look like? The first leaked images from the Intercept mission were paradigm-shattering. 3I Atlas's surface resembled no comet on file. Imaging analysts flagged a pattern of smooth, almost metallic-looking plating, broken by lines that ran too straight to be natural fractures. One analyst, quoted in a redacted chat log, called it the radiator problem, referring to a gridwork of raised ridges spaced like the cooling fins on spacecraft. These ribs cast long, uniform shadows, and their regularity caused the anomaly detection software to flag the pattern as artificial. Comparisons to known comets like Halley or 67P Churyumov-Gerasimenko fell apart. Their surfaces are jagged and chaotic. 3I Atlas, in contrast, had long stretches that reflected sunlight like polished alloy. Further spectral analysis of this reflected light showed an albedo inconsistent with any known meteoritic iron, lacking the usual chondritic features. It was too smooth, too reflective, and far too structured. Thermal signatures and heat pulses. If the surface looked engineered, the thermal data was even more alarming. According to the leaked files, infrared arrays recorded heat vents pulsing with incredible regularity. The logs show heat pooling along the strange ribbed seams, and then bursting outward in tight, directed jets. This wasn't the broad, chaotic outgassing you see in a typical comet. These were discrete, timed pulses occurring precisely every 90 seconds, raising local surface temperatures by over 200 degrees Kelvin in an instant. The mission logs classified this as a directive motion event, a term typically reserved for spacecraft thrusters, not natural phenomena. Even more damning, trajectory analysts correlated these thermal pulses directly with the object's mysterious course corrections. After each 90-second heat burst, the Intercept team logged a subtle but precise shift in its path. The efficiency of this propulsion, measured as specific impulse, was calculated to be far beyond any chemical rocket, consistent with advanced ion or plasma thrusters. Gravity couldn't explain it, solar radiation is constant, and natural outgassing is random. The evidence was building 3I Atlas wasn't just moving strangely, it appeared to be actively propelling itself. Chemical composition mysteries. The mystery only deepens when you look at what 3I Atlas was made of. Martin Cordner's team at Goddard was the first to get a full spectrum after the Intercept, and the results were an instant red flag. The early spectra lit up with incredibly sharp, bright lines of nickel. In cosmic bodies, nickel almost always rides shotgun with iron. Yet in every single frame of data from 3I Atlas, iron was almost completely absent. Its signature spectral lines were missing. This isn't just rare. In the entire catalog of known comets and asteroids, it's unheard of. The natural formation processes that create asteroids from protoplanetary disks simply don't separate these two elements with such purity. Leaked notes suggest the isotopic ratio of the nickel was also wrong, indicating it wasn't formed in a typical supernova. The purity level was estimated to be over 99.8%, a level that on Earth requires an advanced electrochemical process known as the Mond process. Radio echoes and communication patterns. Beyond its motion and materials, the most chilling evidence in the leaked files points toward active technology. According to the logs, radio astronomers reviewing raw data from the Intercept mission flagged a pattern of faint, repeating echoes in the X-band frequency range. These weren't natural radio bursts or cosmic static, they were precise, clipped signals with a high signal-to-noise ratio, bouncing back from 3I Atlas at regular intervals. What made this truly shocking was the timing. The interval of the radio echoes mapped almost perfectly to the 90-second rhythm of the object's thermal pulses. It was as if something was pinging the object, and the heat pulses were the response. In one of the leaked chat logs, a veteran telemetry specialist reportedly wrote, It's like someone is pinging the probe and it's answering. The pattern is too tight for random noise. This completely changed the nature of the investigation. SETI pioneer Dr. Jill Tarter has long argued that a truly intelligent signal would likely be efficient and information-dense, characteristics that align with these alleged repeating echoes. The data suggested it could be an active, responsive probe. Expert analysis and propulsion theory. You can't discuss these anomalies without bringing in a voice of scientific courage like Avi Loeb. The Harvard astrophysicist, who famously staked his reputation on Oumuamua being alien technology, wasted no time weighing in on the 3I Atlas files. He argued the intercepted telemetry read like a blueprint for an advanced propulsion system. Each 90-second heat pulse and corresponding course correction was perfectly consistent with a massive ion drive or a similar engine. In Loeb's words, if you wanted to navigate through a solar system while managing heat and energy, you would use timed, directional thrust. That is what the data shows. But the most jarring evidence was a fragment recovered by the interceptor's dust collector. A leaked lab memo described a fleck of material with a lattice of silicon and doped phosphorus, arranged in layers spaced at micron intervals. The structure was noted as being radiation-hardened to a degree far beyond current human capability, suggesting it was built for long-duration travel through the harsh interstellar medium. This wasn't just a circuit, it was an artifact from a civilization far beyond our own. So, what do we make of all this? A 26-kilometer object from another star system, moving at impossible speeds, making its own course corrections. It has a surface that looks like armor, a composition of refined nickel, and it pulses with heat and radio echoes on a perfect 90-second clock. And finally, there's a fragment of what appears to be a microchip. The leaked files, if authentic, present a disturbing and profound reality. The questions are staggering. What is this object's purpose? Where did it come from? And perhaps most importantly, what else has NASA found that we don't know about? Don't forget to like, subscribe, and hit the bell icon for more deep dives into the secrets of science and technology. Thanks for watching Simply Science. A rare visitor from deep space is flying through our solar system, and this one is, honestly, mind-blowingly mysterious. 3I Atlas came from beyond our solar system, making it only the third confirmed interstellar object ever discovered. But, new data from NASA and international observatories suggests this ancient traveler might be something far more extraordinary than just another comet racing past the sun. The breaking discovery. On July 1, 2025, astronomers using the NASA-funded Asteroid Terrestrial Impact Last Alert System telescope at Rio Hurtado, Chile, made a breakthrough discovery that would, captivate the global scientific community. They detected a moving object initially designated as A11PL3Z, later confirmed as 3I Atlas, representing the third known visitor from beyond our solar system. This rapid confirmation was achieved through combined efforts of international observers, including the Minor Planet Center and researchers at NASA's Jet Propulsion Laboratory. The object's initial detection proved challenging due to its faintness and location near dense star fields close to the galactic center in the constellation Sagittarius. High-precision astrometric measurements soon revealed its distinctive hyperbolic trajectory and extreme velocity, definitively eliminating the possibility it belonged to our solar system. 3I Atlas's discovery immediately energized astronomers worldwide, sparking an unprecedented campaign of rapid, coordinated observations designed to track this rare interstellar visitor, while maximizing data collection before it became too dim to observe effectively. This extraordinary find underscores the remarkable capabilities of modern telescopic survey systems in uncovering objects once believed completely undetectable, opening new scientific horizons for comprehensive interstellar object research. The discovery story. Between June 25 and 29, 2025, the Atlas survey system, composed of 4 powerful telescopes strategically located in Hawaii, Chile, and South Africa, captured multiple critical detections of the newly discovered object, now officially known as 3I Atlas. The initial observational data appeared as extremely faint streaks against the dense starry backdrop, but gained tremendous scientific significance as coordinated follow-up observations quickly pinpointed its precise celestial path. Simultaneous observations from the Zwicky Transient Facility at Palomar Observatory in California strongly supported by dedicated researchers like Marco Micheli from the European Space Agency and Daryl Seligman from Michigan State University, helped definitively confirm the object's unbound hyperbolic trajectory, providing compelling evidence supporting its confirmed extrasolar origin. The survey system's remarkable ability to rapidly scan vast areas of sky using advanced wide-field imaging technology proved absolutely critical in detecting this extraordinarily rare interstellar visitor amidst the incredibly dense stellar population near the galactic center, where precise object identification remains notoriously challenging. Extensive archival searches later uncovered valuable pre-discovery observational data dating back to June 14th, definitively revealing that this ancient comet had been silently traversing our solar neighborhood for several weeks before achieving formal astronomical recognition and official designation. A stranger in our midst. What makes 3I Atlas truly extraordinary are its unprecedented physical characteristics that, honestly, challenge conventional understanding of interstellar objects. Moving at an absolutely mind-boggling speed of approximately 58 kilometers per second relative to the Sun, this cosmic visitor dramatically outpaces both previous interstellar visitors, Oumuamua and 2I Borisov. Its extreme orbital eccentricity of 6.14 represents the highest value ever recorded for any known celestial object, creating an almost perfectly straight trajectory through our solar system. Initial size estimates suggested the object could measure up to 20 kilometers in diameter, making it potentially the largest interstellar visitor ever observed, though recent Hubble Space Telescope observations indicate a more modest size between 0.32 and 5.6 kilometers. The comet's unusual brightness patterns and early activation, while still 4.5 astronomical units from the Sun, have puzzled researchers worldwide. Unlike typical comets that remain dormant at such distances, 3Y Atlas began displaying cometary activity far earlier than theoretical models predict, suggesting either unique composition or potentially artificial characteristics. Its trajectory alignment with the ecliptic plane occurs with only a 0.2% probability by random chance, raising questions about whether this positioning might be deliberate rather than coincidental, adding another layer of mystery to an already enigmatic cosmic visitor. The predecessors. The discovery of 3I Atlas follows two other remarkable interstellar visitors that, really revolutionized our understanding of cosmic wanderers. Oumuamua, discovered in October 2017 by astronomer Robert Warwick at the University of Hawaii, became the first confirmed interstellar object. It measured roughly 400 meters long and had this unusual elongated shape. Its mysterious acceleration patterns sparked intense scientific debate, with some researchers even proposing exotic explanations including possible artificial origins. 2 years later, amateur astronomer Gennady Borisov discovered 2I Borisov in August 2019, which turned out to be a more conventional interstellar comet with typical outgassing behavior and composition. These three visitors demonstrate that interstellar objects may actually be far more common than we previously believed, with improved detection capabilities now revealing a steady stream of cosmic travelers passing through our solar system. The objects display varying characteristics. Oumuamua appeared asteroid-like with no visible coma. Borisov behaved like a typical comet, while 3I Atlas exhibits these hybrid features that just don't fit established categories perfectly. This progression suggests our solar system regularly encounters material ejected from other stellar systems throughout the galaxy, providing, honestly, unprecedented opportunities to study the composition and formation processes of distant planetary systems, without needing to mount expensive interstellar missions to reach them. The cosmic journey. 3I Atlas follows a precisely calculated path through our solar system that brings it tantalizingly close to multiple planets during its brief visit. The comet will reach perihelion on October 30, 2025, approaching within 1.36 astronomical units of the Sun, positioning it between Earth and Mars at its closest solar approach. During its journey, the object will pass remarkably close to several planets: 0.19 AU from Mars on October 3, 0.65 AU from Venus on November 3, and 1.8 AU from Earth on December 19, 2025. These planetary encounters offer honestly unprecedented scientific opportunities to study an interstellar visitor using various spacecraft instruments and ground-based observatories positioned throughout the solar system. The comet's retrograde orbit, inclined 175 degrees relative to the ecliptic plane, means it travels opposite to the planet's orbital motion, adding to its mysterious nature. Computer models tracking its future trajectory indicate 3I Atlas will eventually pass 0.36 AU from Jupiter on March 16, 2026 before departing our solar system forever. This cosmic journey provides a once-in-a-lifetime opportunity for comprehensive multi-wavelength observations, gravitational studies, and potential spacecraft encounters that could, really unlock secrets about the formation and evolution of planetary systems beyond our own solar neighborhood. A scientific goldmine. The arrival of 3I Atlas presents astronomers with an unprecedented scientific opportunity to study pristine interstellar material using cutting-edge technology that just wasn't available during previous visits. NASA's Hubble Space Telescope captured detailed images in July 2025, revealing the comet's coma structure and dust distribution patterns. The James Webb Space Telescope is conducting comprehensive spectroscopic analysis to determine the object's chemical composition, searching for exotic materials or isotopic ratios that differ from solar system objects. Ground-based observatories worldwide, including the Gemini Observatory and Keck Observatory, are monitoring brightness variations and rotational periods that provide insights into the comet's internal structure and density. Advanced computer modeling allows researchers to simulate the comet's behavior under various theoretical scenarios, testing whether observed characteristics match predictions for natural formation versus artificial construction. International collaboration through organizations like the European Southern Observatory ensures continuous monitoring across multiple wavelengths and time zones. The wealth of data being collected right now far exceeds anything obtained from Oumuamua or Borisov, potentially revolutionizing our understanding of interstellar objects, planetary formation processes, and the dynamic environment between stellar systems. This comprehensive scientific investigation may, hopefully, provide definitive answers about 3I Atlas's true nature and origin before it disappears into interstellar space forever. Unanswered questions. Despite intensive international observation campaigns, 3I Atlas continues to pose fundamental questions that challenge our understanding of interstellar objects and their origins. The comet's exact size remains uncertain due to its surrounding coma of reflective dust, which obscures the nucleus and complicates accurate diameter measurements. Early estimates range from 1 to 2 kilometers to potentially 20 kilometers across, representing enormous uncertainty that affects calculations of mass, composition, and internal structure. Dr. John Noonan at Auburn University suggests the nucleus is likely on the smaller end of this range, comparable to 2I Borisov, but definitive measurements await future observations. The object's unusual chemical composition, revealed through spectroscopic analysis, contains isotopic ratios that don't match typical solar system materials, raising questions about the stellar environment where it formed billions of years ago. Its remarkably preserved surface state, despite potentially eons of cosmic ray exposure, challenges models of interstellar weathering and erosion processes. The comet's early activation and controlled outgassing patterns differ significantly from known cometary behavior, suggesting either exotic ice compositions or, possibly, artificial regulation mechanisms. Most puzzling is the statistical improbability of its trajectory alignment and planetary encounter sequence, which some researchers argue exceeds reasonable expectations for random cosmic debris, opening discussions about whether 3I Atlas might represent something more deliberate than natural space debris. The alien question. The possibility that 3I Atlas represents artificial technology rather than natural cosmic debris has sparked intense scientific debate, led prominently by Professor Avi Loeb from Harvard University. Loeb, co-founder of the Galileo project dedicated to searching for extraterrestrial technology, co-authored a controversial paper suggesting the object could potentially represent hostile alien technology based on its unusual trajectory and behavioral patterns. His analysis points to the object's statistically improbable path through our solar system, perfect timing for planetary encounters, and controlled thermal emissions as potential evidence of artificial origins rather than random cosmic wandering. However, the majority of mainstream astronomers strongly reject these claims as premature speculation lacking sufficient evidence, emphasizing that natural explanations remain more plausible for all observed characteristics. Critics argue that entertaining artificial hypotheses without definitive proof undermines scientific credibility and promotes unfounded conspiracy theories about extraterrestrial visitation. The debate highlights fundamental questions about scientific methodology when confronting potentially paradigm-shifting discoveries. Should researchers explore all possible explanations regardless of how extraordinary, or maintain conservative approaches that prioritize conventional interpretations? This controversy reflects broader tensions within the astronomical community about balancing open-minded inquiry with rigorous skepticism when studying objects that challenge established models of natural phenomena and cosmic evolution. Observing the visitor. Astronomers worldwide are employing every available technological resource to study 3I Atlas before it fades from observable range forever. NASA's Hubble Space Telescope continues capturing high-resolution images to monitor changes in the comet's coma and potential tail development as it approaches perihelion. The Swift Observatory is measuring water vapor emissions and ultraviolet signatures that provide insights into the comet's internal ice composition and sublimation processes. Ground-based facilities, including the Very Large Telescope in Chile and Mauna Kea observatories in Hawaii, are conducting continuous photometric monitoring to detect brightness variations, rotational periods, and potential outburst events. Radio telescopes, including the Green Bank Observatory, are searching for any electromagnetic emissions that might indicate artificial communication systems or technological signatures hidden within natural thermal radiation. Advanced spectroscopic instruments are analyzing the comet's chemical fingerprints across multiple wavelengths, comparing isotopic ratios and molecular compositions with known solar system materials and theoretical predictions for interstellar objects. Amateur astronomers using sophisticated backyard telescopes are contributing valuable time series observations that fill gaps between professional facility scheduling. This unprecedented global observational campaign represents the most comprehensive study ever conducted of an interstellar visitor, potentially providing definitive answers about 3I Atlas's true nature and implications for our understanding of cosmic intelligence and planetary system evolution. Dawn of a new era. The discovery of 3I Atlas marks the beginning of a revolutionary era in interstellar object detection and analysis, fundamentally transforming humanity's understanding of our cosmic environment. Dr. James Davenport emphasizes that upcoming facilities like the Vera Rubin Observatory are expected to revolutionize detection capabilities, with projections estimating dozens to hundreds of similar discoveries during its operational decade. This technological advancement will enable comprehensive statistical studies of interstellar object populations, their frequency, composition, and origins, providing unprecedented insights into galactic dynamics and planetary system evolution throughout the Milky Way. The European Space Agency's JWST Spectroscopy Division continues developing new analytical techniques specifically designed to distinguish between natural and artificial characteristics in future interstellar visitors, preparing for potential discoveries that might challenge fundamental assumptions about cosmic intelligence. Advanced computer modeling and machine learning algorithms are being developed to rapidly process vast amounts of observational data from multiple sources, identifying subtle patterns and anomalies that might escape human analysis. International cooperation frameworks established during the 3I Atlas investigation will serve as templates for coordinated responses to future discoveries, ensuring maximum scientific return from these rare cosmic opportunities. The broader implications extend beyond astronomy, potentially affecting planetary defense strategies, exobiology research, and humanity's philosophical understanding of our place in a universe that may be far more dynamic and populated than previously imagined. As 3I Atlas continues its journey past the Sun, it leaves behind more questions than answers about the true nature of interstellar visitors. Whether this ancient cosmic wanderer represents natural debris from a distant star system, or something far more extraordinary, its discovery has opened new frontiers in astronomical research. The truth about 3I Atlas may reshape our understanding of intelligence in the cosmos. Keep exploring with Simply Science. Like, share, and subscribe for more cosmic revelations.